All right, the transformations quiz review. Here I gotta like sketch my images back on there, but then we'll solve the problems together. So for number 1, let me move this closer actually real quick. Okay, for number 1, we have the triangle ABC given to us right here. And we're asked to translate the image according to the vector 3, -5. Now, remember the vector is referencing x-axis first and then y-axis second. It's not an ordered pair, but it's telling us the directions regarding the x-axis with this number and then the direction regarding the y-axis with this number. So what this is claiming is that the x-axis goes left and right. So it's a +3, meaning that we would go to the right 3. And of course, the y-axis is the up and down axis, and it's -5, indicating to us that we would go down 5. So let's take these points, A, B, and C, and let's do one at a time and go right 3 and down 5. So let's look at A first. We'll go to the right 3, 1, 2, 3, and then down 5. So 1, 2, 3, 4, 5. I'm gonna have to, oh, that's perfect. Okay, 1, 2, 3, 4, 5. There we go. So that's where A prime would go. And we can do that for B as well. For B, we can go 1, 2, 3 right, and then 1, 2, 3, 4, 5 down. We have B prime. And of course, C prime as well. Going 1, 2, 3 right, and then 1, 2, 3, 4, 5 down. And we have our triangle. So it's just a matter of understanding the vector is direction. In this case, direction is right 3 and down 5. Now, number 2, it's got 2 graphs already drawn for us. So I have to put those back up here. We have, let's see here, you got -4, 1, -2, 4, and 1 at 1, 3. So you have this first triangle. This is our pre-image because it's A, B, and C. And then our image is -1, -4, -1, or 1, -1, and 4, -2. So this is our image, which is A prime, B prime, and C prime. So what we have to find out is, we're kind of doing the opposite of what we just did, which is now we have to figure out what vector was used to actually make this translation. So you really just need to take 1 point. You don't have to do all 3, but I mean, they should be the same for all 3. So let's take A, for example, and let's figure out how we get from A to A prime. All right. So it's very important that you start at A and work your way towards A prime, and not the other way around. If this ended up being like a regular A and this one up here was A prime, then we would, of course, go this way. So just keep that in mind. Be on the lookout for A to A prime, because this is your pre-image to your image. So from A to A prime, let's see how far over. We have to go to the right. So how far to the right we need to go? 1, 2, 3. That's about level. So we have to go 3 to the right. And then how far down do we have to go from here to A? So we'd have to go down 1, 2, 3, 4, 5. So we'd have to go down 5. So it's actually the same vector that we saw a second ago, coincidentally. Going right 3 and down 5. So it would be 3, -5. Okay, so now number 3. Let me draw our image real quick, or pre-image. We have -1, -3, 3, -3, and 3, -1. Okay. So this is our ABC. And the vector we're going with is -1, 4. So -1, remember, regards x-axis. So this is going to go left 1. And then the 4 regards the y-axis. So it's positive. So it's going to be up 4. So we have to count left 1 and right 4. So from A, we'll start there. We'll go left 1 and right 4. So 1 and then up 4. I'm sorry. 1, 2, 3, 4. That puts us right here for A prime. And we'll do it for B as well. For B, we'll have to go right 1 and then up 4. 1, 2, 3, 4. That puts us there. And for C, go right 1 and up 1, 2, 3, 4. That puts us there. So there's our translation. Right, left 1 and right and up 4. I probably said the wrong thing 1,000 times, but I showed you how to do it, so that's all that matters. All right, number 4. Again, let me take a second to draw the picture up here, and then we'll do the same thing we did in number 2. So we have -5, 1. We have 0, 6. And we have 1, 1. So we have this triangle. So this is actually the image because it's A prime, B prime, and C prime. And the other triangle is a pre-image, -2, -4, 3, 1, and 4, -4. So this is actually the regular pre-image. This is A, B, and C. So we have to work our way from A prime, B prime to C prime. So A to A prime, we have to count this direction. So let's start by looking at how far left we'd have to go. So we do have to go left. We'd have to go 1, 2, 3 to the left. So 3 to the left. Let me make a note of that. And how far up do we have to go? We'd have to go 1, 2, 3, 4, 5 up. All right. Seems like this is a common theme sort of here. So 5 up. 5 up. So what that would tell us, as far as our component form goes, is 3 left would be a -3 for the x, and then 5 up would be a +5 for the y. All right, so now number 5, complete the table, draw the pre-image and image. So let's sketch out the pre-image real quick. So our pre-image is the points -1, 1, 1, 4, and 5, 1. So these are the points that were given to us. Let's go ahead and graph them. -1, 1, 1, 4, and 5, 1. Okay. So this is our pre-image triangle for A, B, and C. So now the image, we're going according to the vector -3, -6. So -3 regards our x-axis. So our x-axis that's telling us left 3. And our -6 is regarding our y-axis. Our y-axis being negative would go down 6. So that's what we're going to do for each point. Let's start with A to A prime. Now the way you could do this to fill in these parts is this is subtracting 3 and subtracting 6. So subtracting 3 from the x's, subtracting 6 from the y's. So if we take this x value and you subtract 3, -1 minus 3 would be -4. And if you take the y value 1 and subtract 6, 1 minus 6 is -5. And we could do that for the other points as well. So we have 1, and we're subtracting 3, so that would be a -2. And then the 4, we subtract 6, and we'd have -2. And then last one, the 5, subtract 3 would be 2. And the 1, subtract 6 would be -5. So these are the points of our image, A prime, B prime, C prime. So again, what we essentially just did was we took our x values and subtracted 3, and we took our y values and subtracted 6, y minus 6. So all these x values, we subtracted 3 from them and got those. And all the y values here, we subtracted 6 from them and we got those. So you could, of course, count left 3 and down 6, and we should end up at the same exact points. And let's see if that's the case here. So we have the point -4, -5 for A prime. And if you count that out, that is 1, 2, 3 to the left, and 1, 2, 3, 4, 5, 6 down. Exactly what the vector described. So, but to fill in the table, it's easier to just do the subtraction for each x and each y. But we'll put B prime is at -2, -2, and C prime is at 2, -5. So let me try and make those a little straighter. All right. And so there's your triangle. You got everything moved accordingly. Left 3 and down 6. Or subtract 3 from the x's, subtract 6 from the y's. All right, now number 6. We have a figure drawn on our graph. So let's see. We have P, which is at -2, 3. We have Q, which is at 2, 5. We have R, which is at 5, 3. And we have S, which is at 1, 1. So we have this like parallelogram shape. And we're reflecting it across the x-axis. Now, our x-axis, let's see. Let me write these down real quick. P, is it P? Yeah, P, Q, R, S. So our x-axis reflection, I don't have my notes on me anymore, but our x-axis translation, or not translation, reflection, follows the rule x, y translates to x, negative y. So let's take all our points and let's follow that lead. So P is at the -2. This is for the x-axis, of course. Translation. So -2, 3. Q is at 2, 5. R is at 5, 3. And S is at 1, 1. So let's follow this lead. Keep x the same, but negative y. So this would become -2, -3. This would become 2, -5. This would become 5, -3. And then 1, -1. So let's plot all of those points as our P prime, Q prime, R prime, and S prime. And we should have our reflection. So -2, -3 would be here. 2, -5 would be here. So this was P prime. This would be Q prime. 5, -3 would be here. This would be R prime. And 1, -1 would be here. This would be S prime. And so this would be our reflection across the x-axis, of course. Now, if we want to reflect across the y-axis, our y-axis rule is similar, but a little different. Our y-axis rule is x, y would translate into -x, y. So the figure that we have is w, x, y, z. W is at 1, -2. 1, -2. X is at 3, 4. 3, 4. Y is at 5, 4. And Z is at 5, -2. So to reflect this across the y-axis, we're going to follow that rule, -x, positive y. So, or -x, same y. So this would become a -1, -2. This would become a -3, positive 4, -5, positive 4, and then -5, -2. So let's plot those new points. Let me get a different color. Good. All right. -1, -2 would be here. This would be for W prime. -3, positive 4 would be here. This would be for X prime. -5, positive 4 would be here. This would be for Y prime. And then -5, -2 would be here for Z prime. And we have our reflection. So that works out. That works out pretty well. Number 8 and 9, you follow the same rules. I'm going to skip them just because of saving time, but they are essentially the same rules. Just make sure you can write down the points and then the rule for it, and you should be good to go. I will do number 10 though. So number 10, we've got, let's see here. We have A is at -5, -1. Let's go ahead and write that in. -5, -1. We'll plot it as well. -5, -1 is here. B is -2, -1. So we'll plot that as well. -2, -1 would be there. So that was A. This is B. And C is at -3, -5. -3, -5. All right, -3, -5. All right, that's C. All right, so we have our image, or yeah, our pre-image. Now we're reflecting it across the line y equals -x. Now this rule is xy translates into -y, -x. Everything becomes reversed. So if we take that with all these points, then we'd have a +1, +5. We'd have a +1, +2, and we'd have a +5, +3 for all of those ordered pairs. So let's try and plot those points, and we'll see our reflected image. 1, 5 is here. This is for A prime. 1, 2 is here. This is for B prime. And then 5, 3 is here. This is for C prime. And there's our reflection. If it doesn't look like a reflection, remember where we're reflecting it across. We're reflecting it across the line y equals -x. Y equals -x is this diagonal. So, if you tilt your screen a little bit, you'll see that, hey, that is kind of a mirror image. It can almost look sort of like bat wings in a way, if you tilt it a little bit. So it is a good mirror image. It is a good reflection. Just follow the rules and you're good to go. So that's the rule there for y equals -x. Simple as that. All right, now rotating 90 degrees, 270 degrees, all those, we follow the rules for those as well. So where's my picture at? All right, so number 11, we have A at 1, -2. We have B at 4, -2. And we have C at 4, -5. All right, so we're going to rotate this 90 degrees counterclockwise. All right, so let's see if I can remember the rule for this real quick. So XY would translate into, let's see, I know it's going to be YX, but which one's going to be negative YX? I believe that's the rule. You're going to have to check. I don't have the notes in front of me. But let's see. So we have A is 1, -2. B is 4, -2. And C is 4, -5. So if we translate according to that rule that I think I've got correct, then this would become +2, 1, which would be here. Oh, I'm sorry, messed that up. Would be here. There we go. 4, -2 would become a +2, 4. Let me do this in blue, actually. Well, I'll graph them in a second. And the last one would become +5, 4. So let's plot those points and see if it worked. So we have 2, 1, which is there, 2, 4, which is there, and 5, 4, which is there. So yeah, that I got the rule correct there. So there's our rotation that's taking this shape here, turning it 90 degrees around the origin to end up where we ended up. And remember how we talked about this in class with rotations? I can't physically show you, but if you take a piece of paper, put it over and trace it, and then rotate the paper, you should see it all line up. Or you could just take the paper you're holding itself, rotate it a little bit, and you can see kind of the restructure, what it would look like if you had moved it in that direction. So yeah, it's just rotating. It's just turning. So you can literally turn your piece of paper and you can see kind of the results afterwards too. All right, rotate the figure 270 degrees counterclockwise. So 270 degrees, let me see if I can remember this one. That rule is XY transitions into Y -X. I'm pretty sure that's right. So the image we have is A is at -1, 2. B is at 1, 5. So let's see, -1, 2, it's A. B is at 1, 5. And C is at 5, 2. So this is our triangle, and we are rotating it counterclockwise 270 degrees. 5, 2. All right, so let's follow our rule. So these would all change into, this become 2, positive 1. This would become 5, negative 1. And this would become 2, negative 5. Following our rule of keeping y and then the negative x. So let's see here. Let's do blue. We've got 2, 1. 2, 1 here. We have 5, negative 1, which is here. And then we have 2, negative 5, which is here. So that's good. This is 270 degrees counterclockwise is the same as 90 degrees clockwise, just FYI. So if that helps kind of see it. If you go 90 degrees clockwise, you end up turning it like we do, or of course 270 degrees counterclockwise, you end up turning it like we do. Again, you could just take your paper, rotate it yourself. I mean, I could show you, but I can't. I mean, obviously the screen recorder is not going to show me physically moving my screen. So, but I show you guys in class. Just rotate your paper. You'll see kind of what the image looks like near the end. So yeah, that covers it. I'll just write down the rule real quick for the last problem for 180 degrees. 180 degrees, you go x, y, transitions to negative x, negative y. Pretty simple stuff. So take all your points and just change up the signs and graph your image, and you should be good to go. If you need help with that, let me know. I'm going to see you guys in class and help you prepare for your quiz. Let me know if you have any questions, and good luck. Bye.